Hello and welcome to my do-it-yourself Arduino quadcopter tutorials. In this video, we will go over connecting all the various quadcopter parts on the quadcopter frame, and I will also introduce you to programming your quadcopter. So before we go any further on this slightly longer video, I just want to show you a quick demonstration of soldering the wires. And the reason that I'm soldering these wires is because I want to create this junction where I have one wire that's splitting into two wires. I'm going to use this to power up my receiver and the gyroscope from the Arduino 5 volt power source. And so for that, I need like a wire splitter. Basically I need one wire that's splitting into two different wires, and so that's the reason I'm soldering these wires. And I thought I would just show you a quick demonstration of how I'm soldering these wires. So all you need is a soldering gun and some solder, and then you should be good. So this is how the end product looks like. I've soldered, I've put the electric tape on top of it, and it's all secure and good to go. Okay guys, so what I have right now is I have everything set up over here except the wiring connections. So I'm going to show you the wiring connections in this video. I'm going to begin with the power to the Arduino board. So that's the spiral jack that's going to connect right over here, just like that. And so for the purpose of this video also, I'm going to basically show you all the wiring connections one by one. I will not show you everything set up all together, and that is because there might be so many wires that could easily be distractible. Could easily be could be messy just because I'm taking all the cables from here and mounting it over there. I will when it's complete, I will definitely show you how it looks like, and where are all the cables. But for the purpose of this video, I'm only gonna show you the wiring connections one by one. So that was power to the Arduino. The next is going to be the power from the Arduino to the receiver and the gyroscope. So for that, if you remember, we made this 3-way 1 to 2 cable. So the 5 volt from the Arduino, so that's the 5 volt pin right over here. So the 5 volt from the Arduino goes into the V in for your gyroscope, which is pin 1, and your positive on the receiver. Again, please make sure you check the polarity on your receiver as to which pin is the positive, which pin is negative, and which pin is signal. Okay, so that is this. I'm going to take this out. The next thing is to connect the ground on the gyroscope. And if you look at the wiring diagram, and again, what I'm doing is I'm basically just following the textbook. Okay, I'm only following my wiring diagram. So if there's anything that's not clear to you from here, it should be clear from the wiring diagram. I'm strictly following that. So from the wiring diagram, the ground on the gyroscope is connected to the ground on the digital pin side. But one additional thing is, if you notice, the low voltage status indicator is also connected to the same common ground. Okay, so we have to take care of that. So for that, I made this this wire here. So what I have is the LED connected to the 330 kilo ohm resistor, and that's going to digital pin 12, and then the negative side is going to the ground. And then I also have this another black cable soldered for the common ground that goes into the ground for the gyroscope. Again, it could be a little confusing, so Again, if you strictly follow the wiring diagram, it should be okay. It's very straightforward. So the ground, the black cable goes into the second pin of the gyroscope. All right. So this is the black cable ground. It's soldered to this pin. So what I'm going to do is I'm going to simply put this to ground. There you go. Okay, and then this pin is going into digital pin 12. I'm going to take that and plug into digital pin 12. So there you go. So that's my low voltage status indicator. Okay, so that does the job too. Okay, I'm going to take this out. Okay, the next thing is simply the SCL, which is the clock and the data, and the SDA. Again, one by one, I'll just connect the data, which is pin 3, to the SDA, which is on the digital side. There you go. Very simple, very straightforward. And the same thing, I'm going to connect the SCL, which is the pin 4 on the gyroscope, to SCL over here. Okay, very straightforward. So that will connect your gyroscope to your Arduino controller. Okay, so the next thing we're gonna connect is the receiver. So I already showed you the power connection to the receiver. Again, the ground on the receiver. So the ground on the receiver is just going to connect to one of the grounds we have on the power side. You know, where all the power pins are. So the ground, again, check the polarity on your receiver. Mine is the third pin from the top. So the ground on the receiver connects to the ground on the power side. Okay, very simple plug and play connection. Okay, and then after that, the 4 signal connections, so channel 1, channel 2, channel 3, and channel 4. 4 channel signal connections are just going to connect simply to the digital input 9, 8, 9, 10, and 11. Okay, so again, check the polarity, see which pin is the actual signal pin. Okay, and so I've connected this white wire to the signal pin of channel 1, and then this goes into digital pin 8. Okay, very straightforward. And similarly, you can continue with all the channels. Okay, so signal from channel 2 connects to digital input 9. Okay, again, very straightforward. Similarly, signal from channel 3 goes to 10, signal from channel 4 goes to digital pin 11. Okay, so that connects your receiver. The next thing would be to connect your ESCs to the Arduino controller. And again, we only need the signal. Okay, we don't need any ground from that because we're not using the red wire back output from the ESC. So if you look at the wiring diagram, the front right, which is this motor, front right motor, is going to connect to the signal from that motor is going to connect to digital input 4. So the signal wire from this front right motor is right over here, and that's because I had the wires placed such a way so that it doesn't look messy. So I'm going to connect the signal, which is the orange, from here onto the digital pin 4. So digital pin 4 right over there. Okay, again, this signal wire is for the front right motor, which is this one. Okay, perfect. Similarly, the rear right motor, the signal from that motor goes back to pin number 5. So I'm going to take that out. Rear right, which is this motor, the pin or the ESC signal wire from this motor is this. So I'm going to connect the signal from here to digital input 5, which is right over here. Okay, and similarly you can go follow the the wiring diagram and connect all the wires. I'm strictly following the wiring diagram. If you see, my wiring diagram is right over here. I'm following the wiring diagram. I have some red lines. This was my draft version. I have the full final version on my website, but you can follow the wiring diagram and connect your jumper cable. It's basically plug and play from here on. Okay, so that pretty much is everything. You've connected your gyroscope, you've connected your receiver, you've connected all the 4 ESCs to your Arduino controller, you've connected your power cable to the motor, to the Arduino controller, and that's everything. You have everything connected. The next thing would be to load the program code. So what I'm going to do next is I'm going to connect all my cables. I'm going to place them in such a way that it's easily visible, it's easily understandable, and then I'll show you how the final product looks like, how my final quadcopter may look like when I have all the jumper cables and all the wiring connections done. Okay guys, so programming a quadcopter is not an easy task, and the reason for that is there are four rotors, basically 4 propellers, 4 motors, so there are 4 different sources of thrust on the quadcopter that's maintaining the level of that quadcopter dynamically. So to program a quadcopter from scratch, you need to understand stuff like how a quadcopter operates. What are the equations of motion behind it? How does it get all the PID controls? The PID gains to control the quadcopter and make it at a level stable flight. It has that stability. And so I thought I would bring this up that a good source of this would be the Andrew Gibiansky's paper on this quadcopter dynamics, simulation and control. I leave the URL for this in the description, so that you can access this paper. But basically Andrew goes over the full quadcopter dynamics. He goes over the kinematics behind it, the transformation matrix that you would need for your different frames of reference on your quadcopter. You would go behind the physics, the motors, the torque of the motor and all that stuff. The voltage that's going behind it. And then basically then integrating that into the equations of motion and deriving the equation of motion for the whole quadcopter. So that would basically be used to get your PID gains along with the control that you want to set up. So once you have that, your next step would be to get the PD or the PID, probably the PID control for your quadcopter. With the PID control, it will error out all the disturbances in your quadcopter, and it will have that depending on the PID gains that you provide on your Arduino program, it will automatically provide the movements to correct those differences. So I'll leave this the link to this in the description, so that you can go over the this paper to understand the quadcopter dynamics. So when I started with this, I worked with a company that I co-founded with my partner on Peli Technologies, where we do aerial robotics and automation, and working with them onto developing not just this quadcopter um, um, program, but basically the we're also we're also exploring more capabilities that the quadcopter can do. And then so one of our projects that we're working on is to have a decent sized quadcopter drone act as a fire truck sort of kind of thing, where it will have water um, that can be used to to tackle the fires where traditional fire equipment cannot make it. So stuff like that, is what I'm working with the partners at Peli Technologies, and then so we'll have something soon up. So I want to show you that I have this code that I initially wrote to get all the uh, PID auto tune level. So it's again, you would run that, you get a simulation, you would get your PID auto level tuning, and then you would go from there. But for if you're not familiar with how quadcopter works, if you're not from that background, you want to plug and play solution to programming your quadcopter, I would say go with broking.net. This person I found through YouTube when I was in the early stage of learning how to program a quadcopter. He has an auto level tutorial on YouTube basically that goes over on programming your quadcopter. So over here he goes over all of that stuff. How would you install that? They basically have a plug and play code written that you can download. I have tested this code. It works fine, and with the wiring diagram that I've shown you on my tutorials, this program will work absolutely fine. Actually, I have to give credit to Jupe Broking, the person behind this project. He was my first inspiration to go and make this quadcopter, and I used his tutorial to understand how it all works, and then how would I actually go and make my own quadcopter. So on this website, I will also put a link of this website on the in the description. On this website you can go over the Q&A. You can you have all the FAQs where you can see if any of the um, if any of the questions that you have maybe listed over here, and then you can go on downloads. You can download the complete YMFC AL package. So you can, AL is the auto levels, you can go and download that. Let's go ahead and download this. And so then go over here, let's see, so I'm going to extract it over here. Okay, there you go, these are all the files. So basically, if you go on his website, you will first go on controlling your calibrating your ESCs, and then setting up your Arduino program, and then basically just going for the flight controller. So if you go over here, it's gonna open the Arduino programming interface, and then he has this whole code. So again, this is not my code, this is Jupe Broking's code. So right over here, and you can see this, it's not my code, it's Jupe Broking's code, but I've used this code before, and you can use it too with the wiring diagram that I've given to you. Exactly, it's gonna work. You might need to play around with this PID gains. So that, again, that's where this comes handy. Where I will run this, get the PID gains, approximate PID gains for my quadcopter, put it over here, and then trial by trial and error, I would get to fine tuning these PID gains. So again, if you don't know what PID gains are, again, there are many YouTube tutorials on YouTube that you can go and understand what PID control gains are. For the purpose of my project, that I'm working with Poly Technologies, right over here, I have the program that I'm making is not complete yet. We're still working on the program. However, just if I had to demonstrate it, where I am right now, that would be a completely different YouTube tutorial series. So that's my plan. I'm gonna make another YouTube tutorial on programming your quadcopter from scratch. So I'm gonna have another Arduino program code different than this. This is Jude Broking's code, but we'll go where I will go over each and every part of the program, teach and explain what it is, how it's being used in the Arduino code, and we'll go from there. And so you will learn for how to completely program your quadcopter from scratch. So I'm going to leave you over here, guys, so that you can go on to this website. Again, description, the link to this website is on the it's in the description, so you can go and check it over there. And then you can upload this program, and basically you will have it running over there. you know, yes, you would need to modify these PID gains to make your quadcopter more steady. So that's pretty much it, guys. I hope you guys enjoyed this whole YouTube tutorial, do it yourself Arduino quadcopter tutorial series. I hope I was able to bring some information to you. Again, this is the first time I'm making it. Well, not the first time, but sort of the first real project that I'm showing off on YouTube. So I hope you enjoyed it. I hope there was a learning transfer from my side to yours. And again, if you have any questions, any comments, or any concerns, please feel free to drop in the comment section, and I will be sure to reply back to you as and when I see those comments. So I hope you guys had a good time. Um, Please do not forget to like, share this video, and subscribe to my channel, and have fun making a quadcopter. Thank you. Bye.